Hey, welcome back AP Calculus students. Today we're looking at 5.5 part 2. So we're continuing linearization and all that stuff. So let's just jump into it. It's asking us to use linearizations to approximate square root of 123 and cube root of 123. So when we're doing this, what we're looking for is we're trying to find a number that's pretty close to 123 that has a square root. So in this case, we're looking at 121. Because we know that the square root of 121 is 11. Alright, so we're following our linearization. F of a plus f prime of a times x minus a. Right, and our a is going to be, so we're going to say L of a x equals 121. So actually we should try to just say, whoops, L of 121. And the reason being, the closer the approximation is, our x is to our actual value, the better the approximation is going to be. So we're going to do f of 121, which is square root 121, plus f prime is going to be 1 half 121 to the negative 1 half, and then x minus 121. Okay, let's change colors. So let's start simplifying this. This is going to be 11 plus 1 over 2, and then the negative 1 half is the square root of 121, and the negative sign means it's the reciprocal. So the square root of 121 is 11, and we're going to put that in the denominator because of the negative sign. Then we have x minus 121. So we have 11 plus 1 over 22 times, and now we can put in the x, which is our actual value here, 123. Okay, so 123 minus 121 is going to be 2, so we have 2 11ths, or 2 22nds, sorry, which is equal to 11, and we'll simplify that 1 11th. So this is our approximation. So let's approximate it. 1 or 11 and 1 11th plus 1 divided by 11 is going to be 11.09 repeating. Okay, we might be running out of room here, so we're going to try to squeeze it in. For the second one, this is the cube root. So the cube root that's closest to 123. So it's going to be square root 125, cube root, 125, because that's going to be 5. 5 times 5 is 25, times 5 is 125, so x is going to be 5. Let's do our linearization. So L of 125 is equal to the cube root 125 plus, we got to do the derivative of this, so that's going to be 1/3 125 to the negative 2/3, and then times x minus 125. Okay, so again, we're plugging in all our a's from our formula, and we did the derivative here. Okay, so this is going to be cube root 125 is 5 plus 1/3. Now, when we do this part, we're going to do the cube root of 125. That's the bottom, right? So that's 5. And then to the negative 2, so we're going to do 25 in the bottom here, because 5 squared is 25. And then we have our x minus 125. Okay, let's clean this up a little bit. So we have 5 plus 1 over 3 times 25 is 75 times. Now we can plug in our x. Remember again, our x is, oops, sorry, that's our a actually. All right, so we should say our a here. And then our actual number that we're looking for is 123 minus 25. So we put the actual number in for our x. And then when we calculate this, we do 5 plus 1 divided by 75 times 2. We get 5.026 repeating. Huh, why did that come out weird? Let's try that again. Let's do 1 divided by 75 times negative 2. There we go. And then plus 5. And this is going to be 4.973 repeating. Okay, now we got them. All right, so just a little bit more practice on the approximations and apply them to actual numbers so that you get an idea of how we can approximate. And this is really how the calculator calculates values. They use linear approximations to get ever and ever closer to the actual number. Well, I think they use Newton's method, which we're going to cover in a second. But they do use this to get to an accurate value. Okay, so this next part is differentials, and these aren't too bad. So what it looks like is d of y is equal to f prime d of x. So whenever we're given a value for d of x, we're looking at differentials. So what we're going to do is we're going to take the derivative with respect to x and then plug in the dx after we do our stuff. So let's change colors here. Let's do blue. Okay, so what we're going to do, we're going to go ahead and find the derivative. So it's going to look like 5x to the fourth plus 27, right? And then whenever we do this in differential form, we're going to add on the d of x at the end of our differentiation. So what's going to happen is we're going to plug in our 1 because x is 1. And we're going to multiply it. Our d of x they're giving us is 0.01. So 5 to the 4, or 5 times 1 to the 4th is 5 plus 27 is 32 times 0.01 is going to be 0.32. For the second one, same idea. So we're going to derive it. Sine of 3x is going to be cosine 3x times, we have to remember the chain, right? So times 3, we'll put the 3 in front. And then we're plugging in the pi, so 3 cosine 3 pi dx. And our dx is negative 0.02. Our cosine at 3 pi is the same thing as cosine at pi, so that's going to be negative 1. So 3 times negative 1 times negative 0.02. Do that in your calculator. Three times negative 1 times negative 0.02 is 0.06. Okay, and then one more because it's kind of complicated for this one. Just remember that when we're doing this, we need to make sure that we do our dy dx. So let's go ahead and do both sides. So we're going to do derivative x plus y equals derivative xy. All right, so this is going to be 1 plus dy. Oh, sorry. It's do this again. So this is going to be, let's just write it out, dx plus dy equals, and this one we're going to have to do product rule. We're going to do, u is x, du is dx, v is y, dv is dy. So we're going to do u dv x dy plus v du y dx. Okay, so what we're going to have to do is we're going to solve this for dy. Alright, so we're going to move our, I guess it doesn't matter which one we move. Let's move our dy's to the right. And we'll move our dx to the left. Oops. Minus y dx. Okay, so what happens is those cancel and move over. So on the right we have dx minus y dx equals y, whoops, I canceled the wrong thing. It's actually this cancel and this stays. So we have x dy minus dy. We're going to factor out our dx's and dy's. So this is going to be 1 minus y. We should put the dx in the back. So dx equals x minus 1 dy. Right? And if we're solving it for dy, we just got to divide by 1, or x minus 1. So then we get 1 minus y over x minus 1 dx equals dy, and then we start plugging in our values. So it's saying that x equals 2, if we look at our initial equation, if we plug in 2, let's plug in 2 there, because we need a y to plug in. So we're going to do 2 plus y equals 2 times y. If we're solving this algebraically, then we want to subtract y here. So 2y minus y is y. So 2 equals y. So we have our x, we have our y, we can plug in. So we have 1 minus 2 over 2 minus 1 equals negative 1. We also have to multiply by dx. So dx is 0.05. This whole thing is going to be negative 0.05. Okay, so just some differential stuff. And then the last thing we're going to look at is Newton's method. So for Newton's method, what we're going to do is we're going to guess a first approximation for f of x equals 0. So we can look at our graph. Excuse me, then we're going to use our approximations to get the second, third, fourth, and so on. So the form looks like x of n plus 1, and maybe it's easier if we use if we show our calculator here. Let's move some stuff around so we can do that. Okay. So the problem says use Newton's method to solve for x cubed plus 3x plus 1 equals 0. Okay, so we're going to graph this out because it says a graph helps. So we're going to do x cubed plus 3x plus 1. So we're going to graph this. And what it looks like is this. So if we're just looking at this, right, because we're just approximating it, that looks like that our x, our 0 is 1. So we're going to use our 1. So where it says that guess a first approximation. So f of x, or sorry, where f of x equals 0. I misread that. So let's go back. So we're trying to find a 0, not the y-intercept. So if we look back here, it might look like 0 at, I don't know, 1/3 or 1/2 or 0.03. It doesn't matter as long as your approximation is okay. As we do more and more of these Newton's approximations, we're going to get closer and closer. So I'm going to say 0.03. You guys can guess another one. So let's say that our first guess is about 0.3. Okay, so what we're going to do is we're going to do x of n plus 1. So we're trying to find the next one, right? N plus 1 means we're doing the next one. We already have the first one. So we're going to start with the first thing. We're going to do 0.3. That's our x of n. Minus f of x of n. So we're going to do 0.3 cubed plus 3 times 0.3 plus 1 over, and then f prime, so let's use purple. F prime would be 3x squared plus 3. So we're going to do 0.3 times 3 squared plus 3. So this would be our second, right? So we're going to put our second in here. Let's calculate 0.3 minus, I'm going to put parentheses around the whole top. So 0.3 cubed plus 3 times 0.3 plus 1. Close my parentheses, then my division. Parentheses again here. 3 times 0.3 squared plus 3, close my parentheses, and this is about negative 0.02 or negative 0.289. Is that math correct? Negative 3 minus, oh shoots. Oh no, that's right, times 3 plus 1 plus 3. Okay, everything looks good there, so let's do the same thing. We're putting this number back in. So at this point we probably want to store it, so let's store it in A. So whenever we want to pull this number up here in all these spaces, it'll be the same. So we're going to do A minus A cubed plus 3 times A plus 1 over 3 times A squared plus 3. And then we'll just keep doing that. So A minus let's see if it works if I put big parentheses. Hold on. 0.3 minus big parentheses 0.3 cubed plus 3 times 0.3 plus 1 close parentheses divided by 3 times 0.3 squared plus 3 close. Yeah, it's the same thing. Okay, so let's do the same thing with our A. A minus A cubed plus 3A plus 1 divided by 3A squared plus 3. Enter. So now I get negative 0.322. And then we could do it one more time. Let's do it one more time. So that would be our, actually this would be our third. So let's just do it one more time. So I'm going to store this again in A, store, and we'll do it one more time. So we're doing A minus f of A divided by f prime of A. So A minus A cubed plus 3A plus 1 divided by 3A squared plus 3. And then the fourth approximation is going to be 0.322. So you notice that this number is getting ever and ever closer. Each time we jump, it's a tinier and tinier jump because it's getting closer to the actual answer. So notice this one was 0.3221, and then the last one was 0.3224, which is to 3 decimal places. It's agreeing to 3 decimal places. So the more you do it, the more and more accurate you get it. But after you do it a few times, it's going to be pretty much the answer we're looking for. So there's no sense in redoing it. All right, so that's it for today. Good job.